Right now, as you're watching this video, there is a spacecraft hurtling through the darkness of interstellar space at over 12 kilometers per second, and nobody is listening to it anymore. It launched over 50 years ago, it survived the asteroid belt, it flew past Jupiter, and then it just kept going, forever, into the void between the stars. And NASA essentially said goodbye and moved on. That spacecraft is Pioneer 10. And its story is one of the most haunting, beautiful, and underappreciated chapters in the entire history of human exploration. So let's talk about where Pioneer 10 is right now, what it accomplished, why we lost contact with it, and what it means that a tiny piece of human civilization is drifting through the cosmos, completely alone, carrying a golden plaque addressed to anyone out there who might find it. Because if you stop and really think about that last part, it gets a little overwhelming. Pioneer 10 launched on March 2nd, 1972. From Cape Canaveral. At the time, it was the fastest human-made object ever launched. It was hurled into space on top of an Atlas Centaur rocket and almost immediately broke records. It took only 11 hours to pass the moon. For comparison, Apollo astronauts took 3 days to make that same journey. Pioneer 10 was in a hurry, and it had a very specific destination in mind: Jupiter, the largest planet in our solar system. But before it could get there, it had to do something no spacecraft had ever done before. It had to cross the asteroid belt. The asteroid belt sits between Mars and Jupiter, and for decades it was the subject of serious scientific debate. Some researchers worried that the region was so dense with rocks and debris that any spacecraft trying to pass through would be shredded apart. The density estimates were uncertain. Nobody actually knew how dangerous it would be. Pioneer 10 was essentially a test. It was designed to find out whether deep space travel beyond the asteroid belt was even possible. The spacecraft entered the asteroid belt in July of 1972 and spent the next several months threading its way through. Scientists back on Earth were on edge. Every day the probe survived was a small victory. And it did survive. It emerged from the asteroid belt in February of 1973 without any significant damage. The region turned out to be much less dense than feared. The rocks were spread out over an enormous volume of space, and the chances of actually hitting one were far lower than the worst-case scenarios had predicted. That single accomplishment, just surviving the crossing, opened the door to everything that came after. Every mission to the outer planets, every probe that visited Jupiter, Saturn, Uranus, Neptune, all of them owe a debt to Pioneer 10 for proving the path was clear. Then came Jupiter. Pioneer 10 made its closest approach to Jupiter on December 3, 1973. It came within about 130,000 kilometers of the cloud tops, which sounds like a lot, but in space terms, that is essentially skimming the surface. And what it encountered was extraordinary. Jupiter is not just a big planet, it is a monster. Its magnetic field is absolutely enormous, stretching millions of kilometers into space and trapping radiation in belts that dwarf anything around Earth. Pioneer 10 flew directly through this radiation environment, and nobody was entirely sure it would survive. The radiation doses the spacecraft absorbed were extraordinary. Some of its instruments were partially degraded. Scientists back on Earth watched the data anxiously, wondering if they would lose the spacecraft entirely. But Pioneer 10 held together, and the data it sent back changed our understanding of the solar system forever. It confirmed that Jupiter has a primarily liquid interior rather than a solid one. It measured the planet's enormous magnetic field directly. It returned the first close-up images of Jupiter's atmosphere. Those swirling bands of color, the violent storm systems, the great red spot seen from nearby for the first time. The photographs were stunning. Nothing like them had ever existed before. And then, using Jupiter's immense gravitational field, Pioneer 10 did something remarkable. It accelerated. The gravity assist from Jupiter flung the spacecraft outward at even higher speed, setting it on a trajectory that would eventually take it completely out of the solar system. Pioneer 10 became the first human-made object ever placed on a path to interstellar space. After Jupiter, Pioneer 10 continued outward through the solar system, and NASA kept listening. The spacecraft crossed the orbit of Saturn, then Uranus, then Neptune, then Pluto. Each crossing was a milestone. With each one, Pioneer 10 was in territory no machine built by human hands had ever reached. The signal was getting weaker. That is the brutal reality of deep space communication. Radio waves obey the inverse square law. Every time you double the distance, the signal strength drops to 1/4 of what it was. By the time Pioneer 10 was beyond Pluto's orbit, its transmitter, running on just 8 watts of power, about the same as a dim light bulb, was sending a signal so faint that by the time it reached Earth, it had spread out across an area the size of a small city. NASA needed a 70-meter dish antenna just to detect it at all. But they did detect it. For years, for decades, scientists continued to track Pioneer 10 and its sister spacecraft Pioneer 11, and in doing so, they discovered something genuinely puzzling: the Pioneer anomaly. As scientists tracked Pioneer 10's position over the years, they noticed something strange. The spacecraft was not where it should be. It was decelerating very slightly, too much, by a tiny but measurable amount, and no one could explain why. The deviation was small, roughly equivalent to the gravitational pull of a grain of sand at close range. But it was real, and it was consistent, and it drove physicists absolutely crazy for years. Some researchers speculated that it might be evidence of dark matter interacting with the probe. Others wondered if it pointed to a subtle flaw in our understanding of gravity itself, possibly even a hint toward new physics beyond Einstein's general relativity. The anomaly was so intriguing that it sparked dozens of scientific papers and years of research. The eventual answer turned out to be more mundane, but still fascinating. Careful analysis eventually showed that the anomaly was caused by the thermal radiation pressure from the spacecraft itself. Heat radiating unevenly from Pioneer 10's nuclear power source was generating a tiny but real thrust in one direction, a ghost push from the probe's own warmth. The mystery was solved around 2012, but the years of investigation inspired pushed the boundaries of precision physics in ways that continue to benefit science today. Now let's talk about that nuclear power source, because it is crucial to understanding everything about this mission. Pioneer 10 did not use solar panels. Out near Jupiter and beyond, sunlight is so weak that solar panels become essentially useless. Instead, the spacecraft was powered by radioisotope thermoelectric generators, RTGs. These devices use the heat generated by the decay of radioactive plutonium to generate electricity. They are not nuclear reactors in the explosive sense. There is no chain reaction. They are simply very reliable, very long-lasting sources of heat that can be converted to electrical power. When Pioneer 10 launched, its RTGs produced about 155 watts. That is not a lot, but it was enough to run the spacecraft's instruments and, critically, its radio transmitter. The problem is that plutonium decays. Every year, the power output drops slightly. By the time Pioneer 10 was in deep space, the available power had decreased significantly. Instruments had to be turned off one by one to keep the transmitter running, and eventually, even the transmitter was not enough. The last time anyone successfully received a clear signal from Pioneer 10 was in April of 2002, when the spacecraft was about 80 astronomical units from the Sun. That is 80 times the distance from Earth to the Sun. NASA made several more attempts to contact the probe after that. They detected what might have been a faint signal in January of 2003, and then nothing. The probe went silent, not with an explosion, not with a dramatic final transmission, just silence, spreading outward through space as the probe crossed the threshold of detectability and disappeared from human hearing forever. NASA officially terminated the Pioneer 10 mission on March 31, 2997, 51 years after launch. So where is Pioneer 10 right now? As of 2026, Pioneer 10 is approximately 133 astronomical units from the Sun. That puts it somewhere around 19.9 billion kilometers away from us. It is traveling in the direction of the constellation Taurus, roughly toward the red star Aldebaran. But do not get too excited about that. It will not actually reach the vicinity of Aldebaran for about 2 million years, and by then Aldebaran will have long since burned out and died. Pioneer 10 is still moving, still heading outward. Its velocity relative to the Sun is about 12.2 kilometers per second. It has long since passed through the region called the termination shock, where the solar wind slams into the interstellar medium and slows dramatically. It may have even crossed or be approaching the heliopause, the boundary where the Sun's influence essentially ends and true interstellar space begins. We cannot be certain exactly where it is relative to these boundaries because we can no longer measure its position directly. We know where it should be based on orbital mechanics and the physics of its trajectory, but we cannot hear it. We cannot confirm. Pioneer 10 is beyond our reach, and it will never stop. There is nothing out there to slow it down. No atmosphere, no friction, essentially no other gravitational forces strong enough to deflect it significantly over human timescales. Pioneer 10 will travel through interstellar space for billions of years, possibly for as long as the galaxy itself exists. Which brings us to the most philosophical part of this story. Before Pioneer 10 launched, a young Carl Sagan, then already a respected astronomer, but not